So now we want to consider, okay, if we want to solve for the zeros of a polynomial, what do we do if the polynomial is not factorable? So if it's factorable, we see what we can do. We can break it up into factors and we can employ the zero product rule. What if it's not factorable? Now what do we do? And the answer is really, it depends, of course. There's lots of situations. In the simplest case of the quadratic, there is luckily a formula called the quadratic formula. For higher degree polynomials, it's more complicated and it's not so easy to solve. I'll mention the quadratic formula real quick. We don't want to emphasize that in this class, so I'll just mention it. We're mostly just gonna focus on ones where it is factorable, rather than focusing on how to memorize the formula or anything like that. But you should know how to use the formula, just because it's just like using any formula, right? We want to get used to using formulas, of course. So this formula comes from a technique called completing the square. So basically, if you set this equal to 0 and you complete the square, what you're going to do is you're going to find that your answers for x is your x is equal to negative b. So the b and the a and the c here correspond to your coefficients, plus or minus, because you will get two answers, b squared, square root of b squared minus 4ac, all over 2a. Okay. So if we use one where we saw it's not factorable, like this one, x squared plus x plus 1. So a, b, and c are all 1 in this case. Then x is equal to negative 1 plus or minus the square root of 1 squared minus 4 times 1, which is 4, all over 2. And we can see why it's not factorable. Well, we can't even find the roots, right? Because it's the square root of negative 3. If you know anything about imaginary numbers, complex numbers, you can use that to kind of write an answer for this. But we're not getting into all that. We're just going to focus on the real numbers. Maybe something else like x squared plus 5x plus 3, for example. The one that I accidentally wrote down in one of the videos. Let's see if this one gives us an answer. So if x equals negative 5 plus or minus the square root of 5 squared, which is 25, minus 4 times 1 times 3, all over 2 times 1. So this is negative 5 plus or minus 25 minus 12. So this is going to be square root of 13 over 2. And there's really no way to make it simpler, right? The square root of 13, nothing can be done about that. So we have two answers. We have negative 5 plus root 13 over 2 and negative 5 minus root 13 over 2. So if you were solving these if you needed the zeros, you could throw these in a calculator and get a decimal approximation. And, that's really the best you can do. There's no way to get in a better exact answer here. Okay, so the quadratic formula is really useful. There is a formula for cubics, so third powers, and for quartics, fourth powers, but they're very long, like multiple pages long, kind of long. So they're not really used in practice very much. And once you get to the fifth power, there actually does not exist a formula. So you can actually prove that there's no formula like the quadratic formula for any polynomial with fifth degree or higher. So, because of that, we kind of rely on other techniques. Nowadays with computers, we can kind of just use the computer to find the zeros, of course. But even just with a graphing utility, we could use the graphing utility to kind of tell where the zeros are. And if you get 1 0, you can then do long division, which is another thing we're not getting into. So I'm just kind of talking about, methods that are not really covered in this course, but just in case anybody's curious, like what you would do if you encounter a situation where they're not factorable. these are just kind of things you could do. So sometimes you find the zeros and then you do long division to make the polynomial simpler, maybe into something you can factor, or maybe into a quadratic. There's one theorem that tells you that you only need to look at the first and last term to look at all the possible rational zeros, meaning ones that can be written as a fraction. And that can give you one of those zeros without using any like calculator or anything, and then you can use long division to make the polynomials simpler. So there's a vast sea of these techniques that you can use. I think the most prominent one that's important to mention, of course, is the quadratic formula, because this one is used very commonly. So you don't need to have it memorized, but you should know how to use it if it's given to you. But otherwise, it's not really such a problem nowadays. We have computers. We can just use the computers to find the zeros. There's some more advanced numerical methods for zeros that are really hard to find. Like, if they come out to be really like weird numbers, there's things like Newton's method, which you can use calculus for. That'll give you a really good approximation of them. So there's lots of methods. We're mostly just going to focus though on the factoring method and employing the zero product rule, and then maybe using the quadratic formula if it's given to you, just like we have here.